All right, welcome everyone. Let's get started. My name is Juarez Barbosa Jr., and today I'm going to talk about blockchain and blockchain on Azure. So without further ado, let's start. We prepared several technical resources and free courses for you related to blockchain. So in case you are interested in exploring more after the session today, please scan this QR code or access this AKMS link. Thanks everyone again. Okay, it's a pleasure for me to be here today speaking about something I'm passionate about, blockchain technology. For those of you who don't know me, my name is Juarez Barbosa Jr., and I'm the Azure Developer Engagement Lead, Microsoft Ireland. Here you can see my email address in case you are interested in asking questions about blockchain. We can take them offline. Of course, I'll take some questions as soon as I finish my presentation today. But of course, in case you have more elaborate use cases or ideas, feel free to reach out to me. You can see here my Twitter handle and my social media channels. Of course, feel free to connect with me as well. My Medium blog, actually, I have all the content that I'm going to present here, including the summarized steps on considering how to provision a blockchain network, run a smart contract, and so on. So without further ado, let's start. Let me talk a little bit about my experience. I have 24 years of experience in IT professionally and 8 years as an amateur. I started to program at the age 13 with the Z80 processor, a Zilog processor, 8-bit, and basic language. And then after that, of course, professionally, I have this career here. Out of this experience, I have 9 years in developer relations, developer advocacy, community, and marketing as well, and 15 years, as a software engineer, software architect, and solutions architect. I worked for companies and also participated in communities related to Nokia, IBM in the past, Nokia developers as a global champion, IBM as the global mobile evangelist and thought leader for IBM Mobile when they acquired an Israeli mobile-related company back in 2012. Here in Ireland, IBM Cloud and Watson, and also acted as the technical rock star for IBM Cloud, evangelizing IBM Cloud. I worked for Oracle in EMEA as part of Oracle developers, as a developer advocate and the advocacy and strategy lead. Then I joined Microsoft, and that's my current role, developer engagement lead. As I said, I focus on cloud, DevOps, and primarily, of course, Java, which is my major. I have 23 years of experience with Java since the early days. 8 certifications. So that's my main programming language, but I'm a polyglot programmer as well. And I focus on emerging technologies, things like AI, IoT, and blockchain, of course. Okay. Blockchain-wise, I have almost 5 years of experience because when IBM created the Hyperledger framework as OpenBC, Open Blockchain, I was an employee and I started to explore blockchain technology. Then IBM contributed the code to the Hyperledger Foundation to create Hyperledger Fabric. After that, as I said, I changed jobs and I was working for Oracle and supporting the blockchain projects in EMEA. And now in Microsoft, I also, beyond this collaboration, my role is actually about developer outreach. So I manage all the relationships and related to meetups, external third-party conferences, collaboration with partners in case they are interested in things, related to developers, also workshops, hackathons, and so on. And I wear a technical hat as well. So I support my team in Western Europe, all the countries with blockchain technology. So without further ado, let's start here. So what's blockchain? Blockchain is a technology, that is really important when you consider digital transformation and IT modernization. Why? Because blockchain, as I said, is a technology that we can consider one of those 3 main ones that belong to the so-called emerging technologies, exponential technologies. So along with, IoT and also AI, blockchain, we have what we call the Trinity in emerging technologies. And blockchain is a kind of data store, a database, but a different one because it has several different characteristics. It's a cryptographic database, a cryptographic network. And then when you compare it with the traditional data stores, for example, there are several things that I would say will differentiate blockchain and add, I would say, more security at the end of the day. We have an added layer in terms of security. And it also promotes the decentralization of data, because we have what we call a shared ledger, a shared database. Blockchain, of course, it's not only about this database, but let's start with that because it's really important to understand the differences here, okay? But blockchain, for example, when you have a traditional relational database, for example, MySQL or SQL Server, or a NoSQL database like Cosmos DB, for example, normally, let's say we have a database, and for a relational database, you have a table there. Let's say the address table, and okay, let's consider that I have my address there, my home address, and the house number is currently recorded, considering a record number 120, for example, as number 45, but my actual house number is 80, so the record and the data is wrong. So, in relational databases, there's a way to run a SQL query, for example, a SQL update, and then change and update the data. With blockchain, we don't have that because blockchain, and in the scope of blockchain, the data is immutable. So we have the first concept, a core one called immutability. Okay, so there's no way to tamper with or modify the data, provided that you have a data set on chain. Okay, there's no way to modify that. In case you want to add or maybe change the context of this data set, you have to have a new transaction and also insert a new block and then append it to your chain. That's why we have this name blockchain. It's a chain of blocks, okay? And then it helps with a lot of things. For example, what we can call traceability, because blockchain at the end of the day is really good when you have to track changes related to a given asset, okay? And also the ownership in a secure way. So for example, let's say if you want to track a car part, a container, for example, a mortgage contract, okay? Blockchain is good for that. Why? Because then you can have the entire, I would say, timeline and the history of a given asset with all the events, and there's no way to modify that. And it can help in several different use cases. And for example, dispute situations with COVID, for example, let's say we have a container with vaccines and they have to be kept at, I would say, sub-zero temperature, -80, for example. But provided that there's a change or any problems with the temperature, for example, there's an event, and then you can record that and have that recorded on chain, and there's no way to change that. Okay, so you have a way to actually retrieve the entire history and have the full traceability about this asset, and it can help in dispute situations because you have a single source of truth. Okay, and that's the other thing with blockchain as well, because this shared ledger, it's a decentralized one. You can say, okay, but traditional databases, we have that. I can have, I would say, a database cluster, for example, but remember that normally, even if you have a company A, for example, with a database cluster, okay, and you can have different regions and I would say instances deployed to different regions, at the end of the day, this database belongs to company A, right? But with blockchain, no, because all the participants in a blockchain network, they share the very same copy of that ledger, of that database. So we are decentralizing the data and promoting something that we call the collective ownership of data. And this is good as well, because, for example, as architects, there are several non-functional requirements that we should be worried about and we have to address in order to, I would say, create a strong and reliable, a trustable solution. And one of those, for example, we have to address what we call the SPOFs, the single point of failure, for example. But with blockchain, let's say I have 100 nodes here, but in case I have an outage and I have 40 nodes down, given that all the nodes, they share the very same copy of that ledger, that's not a problem. I can still process the transactions. That would not happen in a situation where you have, for example, the traditional database, the centralized database, for example, and I have company A and company B here, okay, and I have to transact, and let's say I'm using the HTTP protocol, so I have one transaction started here, and I send a request to record something or change a state in a remote database, for example, but in case there's a network outage, for example, regardless if you are using a synchronous or asynchronous approach to it, in terms of fire or forget or an online system, for example, normally you have to, I would say, query to confirm if a given transaction was committed or rolled back. Normally, depending on the scheme, if you are using distributed transactions and two-phase commit, for example, you need to run a compensating transaction. But with blockchain, we don't have this problem because all the participant nodes in a given network, they share a copy, even if there's a failure, because blockchain, in order to confirm the transaction, we have the so-called consensus algorithms. I'm going to explain that shortly, okay? But I can just inspect my local copy, because I have a copy here. So there's no dependency on external systems. And this thing promotes then what I said, the decentralization, the collective ownership of data, the single source of truth, of course, and on top of that, more security, because at the end of the day, this network, we are talking about PKI, public key infrastructure with certificates, key stores, and so on. So blockchain is really good when you consider, I would say, secure and also decentralized networks, because in security, we have the so-called AAA, for example, things like authentication, authorization, auditing, and blockchain, I would say, is all about security. And with that, there are many, many things that we can do actually to consider blockchain as a good technology, a good candidate for your solution. But let's move here and talk a little bit more about this secure database and the shared source of truth. Okay, so this data is stored in Ledger, for example. We have many transactions. So you can perform the transactions, and there's a consensus algorithm. As I said, it varies a little bit if you consider the public blockchain network. I'm going to explain that shortly as well, or permissioned or somehow a consortium network. The public one is good for B2C applications, let's put it this way, and the private one is, the consortium one is more aligned with enterprises and B2B solutions, okay? But the consensus algorithm is interesting because actually in order to confirm this transaction, you need to send first a valid data input, okay? And then you have what we call the smart contract. At the end of the day, it's a kind of a piece of software, like a traditional software, for example, where you can express business logic, but it's an active component somehow because you deploy this contract to a blockchain network and you instantiate it, so it somehow becomes an autonomous, an active software component instead of a passive one. Okay, I have an explanation about smart contracts as well, but this is just to give you a glimpse of what I'm talking about here. Okay, and the ledger can only be updated when all the nodes, they run the contract and they send a confirmation that first the data input is a valid one, and also the contract and the business logic is fulfilled. Okay, just to give you an understanding of blockchain then here, when we start a network, for example, normally the very first block, considering the chain, is what we call the Genesis block, block 0. And then all the other blocks, normally they have a number of transactions, they comprise the transactions and the data set as well. And there's a reference to the previous block, because with this way you can link everything using cryptography, hashes and so on. There's no way to tamper with the data because in case you try to perform something related, a rogue operation or something like that, of course, the hash would be modified and it would invalidate the entire chain. Depending on the solution, of course, like Bitcoin, for example, where we have Bitcoin is a network demanding in terms of processing power, memory, and storage, and also electricity, for example. That's why we have those massive mining rigs in China, for example, okay? But there are other solutions, for example, the permissioned networks, where normally you don't have, I would say, those factors that you should consider. They are more flexible because with blockchain, for example, this block 0 started back in 2009. So far, they say that the chain size is more than 200 gigabytes, for example. Okay, so in order to actually change one transaction, you would need a processing power to revert all the previous transactions to insert something there. At the moment, it's impossible to do that, explaining that in a simple way. But this is just to give you an idea how this chain is composed. Let's talk a little bit about the blockchain networks then. As I explained, we have the permissionless blockchain networks, the public ones, like Bitcoin and Ethereum, for example. So with these, networks, I can, of course, allocate a server, a hardware box, my compute node, for example, and then I can install the mining software for Bitcoin, and I can join the network. I don't have to be authorized. Okay, so that's why we call it. There are several different ways somehow that we can classify blockchain networks, but I would say most appropriate one is to consider permissionless and permissioned networks. And that's why we call it permissionless, okay? Because I can just prepare my node and I can join the blockchain network, Bitcoin, for example, with no authorization, okay? It uses a consensus algorithm called proof of work, so in order to process a transaction, you also need to pay a fee, normally in Bitcoin, for example, or Ethereum, you have ETH, and you have something called gas, okay? But that's the case with the vast majority of public networks. The permissioned ones, normally you don't need crypto coins to perform transactions. You just have to provision your network your way, and have the proper topology in place, and that's it. But the permissioned ones, so the permissionless one, is appropriate for B2C use cases, okay? But the permissioned one is more appropriate for enterprises and B2B. Why? Because with this one, in order to join a network, a consortium, the network founder, because you can start your own network and then start to invite your partners and the participants to join with nodes, as participant organizations. But in order to join, you have to give them the configuration file, the security certificates. So it's a controlled network. You are not sacrificing decentralization, because at the end of the day, we are talking about blockchain here, so you can have several disparate nodes in different regions and different participants. So, for example, let's say that I'm a car manufacturer like Honda, for example, and I started a blockchain network as a founder, and I started to invite my partners, my providers, the dealers, even the consumers. I can create a consumer app, for example, to participate and get full visibility about, for example, they can track a car in case the consumer has acquired a new car, for example. The same thing with the raw materials and the providers, for example. I can track the containers and so on. But with the permissioned networks, it's interesting because, for example, depending on the protocol, actually the protocol, we call it a protocol, but it is a framework like Hyperledger, for example. I can create what we call channels, okay? And the channels, I can create one channel with partners, one channel with providers, one channel for the consumers, and they don't see the other transactions in case they are not participating in a specific channel, okay? So you have a clear separation and isolation in terms of visibility, and this is good for B2B because, okay, in case Nissan or Honda, for example, they consider a public blockchain network to implement a B2B application, the problem is that the transactions they are public ones. Okay, so, and we are talking about their businesses and the core niche, they belong to. So they want to protect the information about the business. So that's why the permissioned one and consortiums, they are more appropriate for enterprise solutions when you consider blockchain. Okay, I have several examples here. I talked about them. We can be quick here. Okay, you can see here Bitcoin, for example, Ethereum, we have Litecoin for the permissionless ones. And the same thing with the permissioned ledgers. You see here Corda, for example, Quorum, Hyperledger, and many other examples, okay? Yes, but where is blockchain valuable? And that's interesting because the first thing, for example, people, they think that blockchain is only about crypto coins and cryptocurrencies, but no, blockchain is good for all the business verticals and marketing niches, because when you consider, for example, things like healthcare, e-golf, for example, insurance, capital markets, retail, supply chain, logistics, manufacturing, you name them, okay? And you have to control assets, normally you have, the business processes and several different use cases that belong to a given business process, and you decompose them into functionalities. All the points where you can identify, okay, it would make sense to add better security here, to decentralize this data, to remove intermediaries because you can expedite the business processes with this single source of truth. And everything else, more, I would say, better visibility, transparency, and traceability. That's a good candidate for blockchain. So you can see the different business verticals here and some use cases, okay? And that's the thing. you can, I would say, start from scratch and implement a blockchain solution, from scratch, a new project, or you can consider your existing applications and extend and augment them with blockchain technology to add all those characteristics that I talked about. Okay, so blockchain is really good for everything. And then considering the criteria here, there are some questions that you can ask, for example, in case you have to cross trust boundaries, as I said, company A and B, for example, if you want to remove single point of failure and promote a collective ownership of data and more transparency, and data ownership and decentralize the application, add better security, all those things that I talked about, that's a good candidate. The same thing with the shared data. You have multiple parties, so you want to promote full transparency, and the clear separation as well, depending on the use case. You can achieve that with blockchain. For things like IDs, for example, there's something called DID, Decentralized Identity. For example, the United Nations, they have a project called ID2020.org, where they are trying to create IDs for people who don't have a birth certificate, and also for the unbanked people, create some bank accounts, and they can use blockchain because there's a concept related to digital IDs, distributed IDs called SSI, self-sovereign identity. As I explained, the AAA in security, when you authenticate, you can prove with a pair of credentials or a security certificate. You can authenticate your entity, your business persona, or yourself, or a given processing entity, for example. But the authorization step, normally, it follows an all or nothing approach, because you retrieve the information about the security roles, for example, and then let's say you have a system, we have the system admin, the one who can access all the functionalities, but maybe the operator can only access use case A and B, for example. But with SSI, considering this authentication and authorization step, you don't have to retrieve and disclose the entire information about your identity and your user. The SSI, the self-sovereign identity, you can selectively just say, okay, I want to authenticate against this system, and I just want to disclose my email address, for example. So this is one more applicability of blockchain, and a very good one, okay, because it changes everything in security. Same thing for requirements for verification, the traceability that I talked about, identity, having a single source of truth. And of course, with that, because several use cases, there are some players, and some use case systems and use case actors where they act as intermediaries, you can, of course, optimize your business process and perhaps, achieve more velocity. And that's a good thing when you are considering your specific market niche and the competition. Okay, let's talk about the most interesting thing in blockchain, smart contracts. As I said, a smart contract at the end of the day, that's just a software component, depending on the protocol or the framework, you can consider different programming languages, things like JavaScript, Java, Golang, Solidity, and so on. Solidity is one language specific to Ethereum, to Quorum, and a number of other blockchain protocols and networks. But at the end of the day, you can consider it a kind of DSL, domain-specific language, but it is actually a full-fledged programming language, okay, where you can express this smart contract, okay? But this smart contract is a software component, but it is smart because, as I said, when you deploy it to a blockchain network, you instantiate it, it becomes active, it can start to listen and watch the flow, and the context, and provided that you have a valid data input, it can run autonomously, and exercise your business use case. And then I would say with the gossip protocol, you have a kind of broadcast. So all the participant nodes that have a copy of that smart contract, they will receive the same data, run it, and then send the information back to achieve what we called the consensus, right? So you have several disparate nodes and several participants validating the smart contract. So that's why blockchain, you amplify the things related to security and reliability, and you can really promote decentralization, but of course have the single source of truth. Okay, normally smart contracts, they run in virtualized computers, and the vast majority of them, we are talking here about containers, things like Docker, for example, and usually you need also container orchestration, and that's one of the benefits with a blockchain platform like Azure, for example, when you consider it. I'm going to explain why. And at the end of the day, then with the smart contracts, we can call blockchain the programmable web, or the Web 3.0, the next step, or the world operating system. Because the way that you can envision, design, and deploy your solutions now is totally different. The way that you can architect, as I said, the way that you promote the data ownership, and the way that you consider your data sets and the data stores, and also with the smart contracts and the autonomous side of that, it's a different way that you can, of course, design your applications and give more transparency and visibility at the end of the day, and use things like a DID, for example, and SSI, where you have more elaborate use cases. But that's it, okay? Let's talk a little bit about development of smart contracts. We have a famous and a very good enterprise framework and protocol here called Hyperledger Fabric, okay? And for Fabric, in case, because blockchain applications, normally we have a couple of components. The smart contract, this is the component that you create to express your business logic, and then you deploy it to your backend, the cloud side. We can call it the blockchain side, right? And that's it. The smart contract is there, okay? So you have, and then you can have the network, the topology, and several different nodes and participants. You have the blockchain network. The other side is, of course, the client application. Okay, so we are talking here about web applications, mobile applications with iOS, with Android, and so on. And for those, you can consider in the scope of Hyperledger Fabric the same programming languages, but also Python, because there's a Python SDK. But even for technologies and language programming languages where we still don't have a blockchain specific SDK, the vast majority of providers, they also have a REST API. And REST is the de facto standard for integration nowadays, because we are talking about HTTP as the protocol, the transport layer, and also possibly JSON as the data format. Okay, so you can, let's say, if you have an existing PHP application or Ruby application, there are ways that you can still consider blockchain, because you can use a REST API to send a transaction and participate in that network. Talking about tools and the tool set here, of course, we have Visual Studio Code with several plugins. Normally for Hyperledger, there's a way to use also the Node.js tool set and so on. But these are the options if you consider the technologies and the technology scope, programming languages, and tools to create Hyperledger applications. I have a blog post about Hyperledger on Azure with Kubernetes. Interesting to say with Azure, because many blockchain providers and players at the moment, the cloud players, they only consider blockchain at the top, because with cloud we have, IaaS, infrastructure as a service, PaaS, platform as a service, and SaaS, software as a service. There's a concept in blockchain called BaaS, blockchain as a service, at the top, at the same level as SaaS, where you encapsulate all the complexity considering this blockchain network. Because blockchain is a complex technology. Why? Because it involves many disciplines in computing. We talked about security here, a public key infrastructure. We talked about distributed computing. We talked about programming languages. We talked about containers, cloud native, Kubernetes, for example, with storage and architecture. So there are many, many things related to blockchain. And if you consider the do-it-yourself approach to blockchain, for example, okay, you can use, I would say, an existing and available open source project and component and protocol, for example, but you have to manage the entire infrastructure. Okay, so it's good for you to consider a BaaS service, but of course with Azure, you can also do it at the platform level. You can see here, for example, my blog post is related to Fabric and Kubernetes, okay, with the Azure Kubernetes service. And even if you want to, I would say, follow this do-it-yourself approach and also have some VMs, for example, at the IaaS level, you can do it, of course, okay? So Azure is really flexible, okay? It's up to you in case you want to move to Azure, but with the blockchain service, for example, we have several different, I would say, things that can facilitate and also accelerate implementation of your solutions, because remember, blockchain is a data store. At the end of the day, it would be useless with no data. it's like data science and AI, for example, okay? In order to optimize your AI model and things like that, you need to have your data to exercise the model. And that's why we have big data as well. The same thing with blockchain. And with Azure, for example, we have several different out-of-the-box connectors, that you can leverage data from disparate data sources like SAP and many others, and connectors, IoT, and so on. That's why it's a good idea not only to abstract all the complexity with this infrastructure and the governance, okay, of this infrastructure, because this is really complex, but also I would say considering integration and all those things, it's really interesting to consider a blockchain platform, okay? We have one more example here, Quorum Blockchain. Actually, this is a project that started with JP Morgan Chase, a bank, an American bank, sorry. And they created Quorum as a fork. If you consider the Ethereum blockchain, they forked it and they started a new project. They created some different approaches to validation and some components and so on. But at the end of the day, it uses Solidity as well as the programming language. You can use VS Code. By the way, Microsoft, we have a very good VS Code extension called the Blockchain Dev Kit for Ethereum, okay? Because, VS Code is a polyglot integrated development environment, the one that developers love nowadays, a lightweight one, so you can have just one tool and you can program in several different programming languages, and we have blockchain there for you as well, okay? Considering Quorum then, we also have, in terms of tools, the Node.js tool set as well, and some specific tools like Truffle, for example, and so on that you use to, I would say, compile your smart contract. I have a quick demo here today to show you everything and so on. But this is one more option that you have. I also have all the steps, of course, in case you want to explore the official documentation. You know how rich Microsoft is in good. Microsoft Learn and the documentation that we have, everything is there for you. But I summarize the steps in case you want to, I would say, stand up a blockchain network and also create a sample smart contract and interact with it and understand how it works and see the consensus and the execution of this contract. I have the demo here considering what I summarized as part of these blog posts. But anyway, it's one more thing that you can leverage, okay? The last one I would like to talk about is Corda. Okay, Corda is started as a blockchain protocol, I would say, focusing primarily on financial services, but currently they can address many different use cases as well. The interesting thing is that Corda only considers the programming languages that belong to the Java ecosystem. Okay, so we are talking about the JVM, the Java Virtual Machine here, and we have Java and Kotlin here as well. And Kotlin is a language created by JetBrains, but at the end of the day, when you compile a source code created in Kotlin, a .kt file, it becomes a .class file. That's Java bytecode, so it runs on top of a JVM. And of course, here we are talking about Java, so you can consider the traditional programming languages and like Java and Kotlin, but also the tools, VS Code, but also Eclipse, IntelliJ, and so on. Okay, but this is a very good option that you have. I don't know, maybe you have an internal IT department and your team, they are skilled in Java, for example, that might be an option for you. But we have Java, for example, considering Hyperledger, okay? So, but this is something interesting to consider, okay? Some samples here as well, how to run a demo Corda network and so on. I have blog posts for that. Let's talk a little bit about Hyperledger as an introduction here. Why? Because I just want to show you internally how one blockchain transaction execute on it, and Hyperledger is the easiest one to show you and give you a glimpse of how it works internally in terms of the smart contract and the data validation and so on. I talked about Hyperledger. It is a project under the Linux Foundation umbrella, under the Hyperledger Foundation, okay? So it follows the same governance model as the Linux Foundation, open source, and so on. It is a permissioned one, so it is good for B2B and enterprises. It has something called the membership services. We are talking about a CA authority, a certificate authority. There's one specific node there to support the entire security in the network. It is modular, so you can create your own components, your consensus algorithms, It is totally pluggable. The same thing with the underlying data stores, in case you want to have a different one, in case you want to implement, I don't know, TCE, trusted computing environments, and things like that. Fabric is modular, so there are ways that you can modify some components, and of course, use that in case you are not glad with the official ones. By the way, for example, Hyperledger and all the blockchain protocols that we support as part of Azure, we don't modify them. There's no proprietary thing about related to proprietary protocols here, because normally Microsoft, we use the upstream open source component. The same thing for Hyperledger. Why? Because the Hyperledger Foundation, we have almost 300 different organizations they are supporting and evolving this protocol. So we have, car manufacturers, airline companies, all the tech giants, banks, and many pharmaceutical companies. They are supporting blockchain, because, as I said, blockchain is good for many business verticals and use cases. Okay, so just to give you a glimpse about some other protocols, of course, Hyperledger Fabric is the main one, but we have, for example, Sawtooth here, where they consider the EVM, the Ethereum virtual machine, a different transaction family, so you can interact with, I would say, things that are more related with Ethereum, for example, and several tools, for example, Caliper. This is good for performance and benchmarking in micro benchmarking, in case you want to optimize your smart contracts. But you can just visit the Hyperledger Foundation and have a look. Let's talk now about the blockchain transaction workflow, as I said. Okay, so on the left-hand side here at the bottom, I have the client application. You can consider that as I said, a web application or mobile application. So the very first step here is the enrollment. And you receive the certification. You can see the MSP, the membership service provider at the top with the CA, the certificate authority. So this is somehow the authentication phase. Okay, you authenticate, the client is authenticated. Okay, so I can submit a request to endorse a transaction now. So I send this request for endorsement. I send the data input. Okay, so the endorser, and this is interesting because this first phase, it is just an in-memory simulation, so you are not modifying the underlying data stores, okay? So with Hyperledger Fabric, we run this initial validation. You receive the data input, and then you relay it to the smart contract. In Hyperledger, we call this smart contract a chain code, okay? It runs against the business logic that you expressed as part of that active smart contract, okay? And then you receive a confirmation, okay, and a support for this endorsement, okay, what we call the signed read-write set, and you send that back to the client, and the client will then relay and send the request for this endorsed transaction, for example, to a component called the ordering service, okay? This ordering service is the one that will batch all the transactions, create the blocks, and it acts as a kind of, I would say, front-end controller, to, I would say, organize and batch all the transactions. In case we are talking about a massive number of transactions here, there's a way to actually use some big data components like Kafka, for example, for the service here to support the service. It receives the transaction batch and then sends it to the committer. And this component is the one that will actually modify the underlying data store and what we call the world state, because at this point in, we have the gossip protocol, so the broadcast and all the nodes that will do the same thing and then send the confirmation, okay? And then you replicate the data. And that's why I talked about the decentralization of data and also the collective ownership of data and more transparency and things that are related to single point of failure and so on, okay? And one last step here, of course, there's a way to implement a kind of callback, for notification. So let's say in case you want to, because we are talking about distributed transactions here, okay? And you can also combine that with microservices and many other technologies as I talked about. But, you can, of course, register a kind of hook, a callback hook, to receive a commit notification, a confirmation that the transaction is, I would say, committed. And then you can implement, I don't know, if you need to send an email message as a confirmation or show a pop-up or maybe move one file with FTP from one server or directory to another and so on. So this is something to support the entire use case flow. Okay, but this is just to give you a glimpse of how it works because this is important. Let's talk now about blockchain on Azure. Our vision, I talked about it, no proprietary ledger, okay, so it's ledger agnostic, no crypto coin or altcoin, because primarily we are talking about permissionless networks here, okay. Of course, Azure, we support hybrid cloud deployments and models and topologies. We consider multi-cloud and multi-ledger, so we support a number of different blockchain protocols. They are there for you at different levels, you know, the BAS level, the PaaS level, and the IaaS level as well. And of course, you know, Microsoft, we have partners like you here today, and, you know, and several different companies and the entire ecosystem and the community to support the solutions. I talked about this, you know, blockchain on your terms, you know, so, you know, Azure, we have a number of regions, you know, more than 60 regions, hybrid approach to cloud. You can, of course, combine that with all the security-related components and services, Active Directory, Key Vault, you name them, you know, blockchain at all levels, as I explained, secure off-chain integration, TCE, compliance, all those security requirements, they are there for you. The specific services, the first one is the Azure Blockchain Service. Okay, so this is the one that I said, you know, is the best service where you encapsulate all that complexity. And this is good because, as I said, for example, let's consider Hyperledger. If I deploy Hyperledger with the network founder and a couple of participant orgs, and in Hyperledger, each organization can have up to 14 nodes. So we are talking about 14 Docker containers, okay? You can consider here, for example, if I deploy the network founder and 2 orgs with 2 nodes, considering the CA node, ordering node, and everything else, I end up needing something around 22 nodes, depending on the topology. But imagine the situation where, okay, I want to implement a blockchain network, and I will have 1,000 partners and 1,000 providers, and I want to have this here with 10 nodes and those with 14 nodes, for example. You have an explosion regarding the number of nodes and the complexity, okay, because you have to manage all the IP addresses, all the ports, certificates, smart contracts, Docker containers, and so on. So this project, you know, in the infrastructure, the do-it-yourself approach to it, it becomes a separate project, you know, and you have to think about things like, of course, security and patching, for example, like the case with an American company, they use it an old version of Struts framework, for example, and some hackers, they exploited the vulnerability and the security hole, for example. So with open source components, okay, you can use them, but you need to have the right approach to patching and, you know, and also the full governance considering this environment. That's why it is really interesting for you to consider the Azure Blockchain Service, because Microsoft will take care of everything. So this is transparent. You should be worried about creating your smart contract, deploy it to Azure, to the blockchain side, you know, the server side, the backend side, the cloud side, your client here to extend or create a new application, and that's it, okay? The second thing we have is the Workbench. Okay, the Workbench is, at the end of the day, you provision, it's good for POCs and pilots. You provision the Azure Blockchain Service, but along with it, you have things like IoT Hub, for example, the message bus, for example, SQL Server, Active Directory. There are several components as part of, I would say, an initial topology. Everything is pre-configured for you, so you can just go and implement blockchain. So it's a kind of accelerator. And the last one, the dev kit. The dev kit, I talked about it. We have the VS Code extension, but we also have several out-of-the-box code samples that you can use to implement several different use cases and combine that with several Azure services to accelerate your solution, okay? So Microsoft, apart from the other cloud players, for example, we are not only giving you the right cloud in the environment to create a blockchain network, but also the accelerators and the code samples and the VS Code as extension, as a tool to create blockchain applications. So we are talking about the experience here from end to end, okay? And I'm going to show you how easy it is to deploy a smart contract. I talked about the dev kit, the same thing with the code samples here. This is the blockchain workbench, okay? So you can see here the topology I talked about. And at the end of the day, as I said, there are several different functional and non-functional requirements as an architect that you have to think about when you are considering a blockchain solution. But with Microsoft and Azure and all the tools and the environment and the options that we give you, you can just focus on writing the business logic. That's effectively the smart contract. Okay, all the other concerns, they are addressed and they are abstracted considering the blockchain as a service solution, Azure blockchain service. Okay, so yes, let's have a quick demo here now. First thing I want to show you a network that I deployed here. I have this resource group here, and I provisioned one member node here. The protocol here is Quorum, for example, okay? And I executed some transactions this morning just to test the environment and show to you. But this thing, for example, this is really interesting because you have a centralized dashboard. We have, for example, the data manager here that you can use for integration and so on. But for example, these metrics here and the consolidated dashboard, in case you are using the do-it-yourself approach in an open source component, you will have to run several specific command line tools with several parameters and arguments and certificates and IP addresses from the command line tool. So that's really complex. So it's a good idea because Microsoft also consolidated all the information in a dashboard for you. You know, you can see it's a GUI here, a graphical user interface. So this is something that can also accelerate the implementation of your solutions. Okay, so I have this node here, and I prepared one sample VS Code smart contract. You can see the dev kit here as an extension, as I said. You can use the portal, of course, the Azure portal, but you can create the blockchain service from here. You can connect to an existing consortium, for example, several steps, interact with your smart contract from this visual environment here as well. You can see the blockchain network here, the Azure blockchain service. CS is a consortium that I created, and the member node that I showed you on the portal. Okay, everything is here for you. And then I have one simple smart contract here. The extension for this file is .sol, you know, so that's a Solidity smart contract. At the end of the day, I told you Solidity is a programming language, so you can see the Solidity specific version here. The contract, it's like a Java class, for example, an enum structure here, like enumerations in C or Java, for example. Same thing here, some variables, you know, the addresses and the state as public, you know, you have the access modifiers here as you have in Java as well, and so on. There's one method here to be implemented, a constructor as usual in object-oriented programming languages, for example, like Java as well, and some methods here. This is a very, very simple smart contract just to show you the interaction. And I included a couple of methods here just to echo the message that we are going to send. But the interesting thing, for example, as I told you, with this tool here, I can just, this is my smart contract. I can right click here and then ask to build the contract. And you can see here, for example, that I started to compile, and it's using behind the scenes the truffle and also the NPX that belongs to the Node.js toolset, you know, to compile the smart contract, you know, so I can skip all the complications and all the command line tools that I have to use with all the parameters. So it is as easy as that, you know. And the same thing with the deployment. I can just right click here and deploy the contract. I can do it later because now I want to show you how to interact with this contract. So let's first connect to our blockchain network. There's a configuration file here I can show you, for example. This one, so this is actually the instance that I created. So when I perform this connection here, for example, if I come to this command palette here and I click connect to blockchain network, I will create this blockchain connection here. And at the end of the day, I have this connection, the composition of my member node and the consortium and everything with the address here, you know, and the protocol and everything else. And also you need a kind of wallet as well to authenticate against it. But with VS Code, you can accelerate it so you see how easy it is, okay? So let's run one transaction from the command line here. I prepared some calls. Okay, first thing I have to connect to a kind of shell, a specific one, okay? So yes, I can do it here now. I hope it works. Okay. Yes. Okay. It is connected. So first, let's inspect. What I have there, so I can just see the current state considering this network. Okay. yes, let me echo the message that I have there. Okay, so I have this. Yep. Oh, okay. So I have this. Hello, Bajan, my good friend. Today you learned about blockchain solidity and Quorum. Okay, so now let's run a transaction. Okay, so I can modify this data, and when I send this transaction, remember the nodes they will receive the proposal, they will validate the data, consensus will be achieved, and then the data will be modified. Okay, so all the clients they will be able to see the very same data. Now I can try to retrieve it. And yes, we modified it. We have Hello Microsoft Partners Security Console now. So that's everything, in order to create the blockchain connection and the network, there's just something that I want to show you here now. Where is it? Here? Yes. So I talked, just to summarize here, I talked about the Azure Blockchain Service and the solutions. So we have the blockchain service as the best solution, the Workbench as the accelerator, and the dev kit. Okay, so for example, here I have the Workbench. I can open this diagram here just to give you a glimpse. So we have on the right-hand side blockchain service here at the bottom, event grid, as I said, IoT hub, service bus, gateway service, for example. So this is good in case you want to pilot a solution with blockchain, because you don't have to configure ever separate and disparate components. They are fully integrated when you provision on the Workbench. The same thing with the dev kit. I told you, for example, there are several different code samples here, so you can combine them with the services and other things that I talked about. There's a GitHub repository. Let's say if you want to send a message with the Twilio platform SMS, for example, there's a code sample there for you, so this is a very good accelerator. And the dev kit, the extension for VS Code, the one that I've just showed you, and the way that you can run the client and accelerate. And this is my blog, so all the steps and the things that I showed here today, you will see that actually I have, for example, for this presentation here, everything, the summarized steps there. I show you how to create a blockchain member and the consortium, for example. Oh, my network is not so good today, but everything is there, is here, and the same thing with the but John, are you still there?
Yes, I am, but I was still
okay, sorry. Yes, I don't know why it's not loading. Okay, so I have the code sample here as well, all the steps, the summarized ones, as I said, so you can use it just to replicate what I executed here today. So I invite you to explore in case you want to, or the official documentation. So feel free. That's it. And the connection here, I can just, for example, as I told you, I can just disconnect from this network here, for example, and then I can just ask to connect again. You will see I select blockchain service here, my subscription. It will load the different, for example, I have this resource group here that I created. I select the consortium, and then I select, I have the connection configured here, Initially, there's a kind of mnemonic that you have to create, but I have everything ready for you. But that's it. That's my presentation. So let me just close here 1 sec. Where is it? Oh, yes. Okay. So the key takeaways here, Azure is a very good cloud when you consider blockchain, because we have all the protocols, we have the tools, we have the code samples, and you can combine that with all the Azure services, including the security related ones. Blockchain and with Azure, you can simplify, the network topology, formation management, the governance, abstract all the complexities that I talked about. And we have partners and customers, you can see several famous logos here, considering the customers, for example, solutions with Starbucks, for example, Volkswagen, and the United Nations, and, even Microsoft, for example, Xbox with UI, for example, at the moment, there's a solution for Xbox games and DRM, digital rights management, and so on. We have, of course, one interesting program here. The last thing, Azure Heroes, we created some blockchain-based badges for you, digital assets. This is interesting because depending on your participation in our developer community, for example, you can get some badges, and they are lifelong ones because the data store for that is Ethereum. So it's different with, for example, if you have a badge with a given provider and that company goes bankrupt, for example, you are not sure that if those badges will be available for you there forever. But with Azure Heroes, as I said, if Ethereum is the data store, the network will be there forever, lifelong ones. And that's it. Thanks a lot again for joining our session today, and I hope you liked the content.